Hello, this is Alan Elliott, and this is SAS Essentials Mastering SAS for Data Analytics, 3rd edition. This is Chapter 9, Introduction to PROC SQL. The learning objectives for this chapter is to find out what is PROC SQL and how is it useful in SAS, some of the SQL nomenclature, the structure of a SQL statement, using the select statement, the from statement, accessing SAS datasets, using the where, group by, having, and order by clause, doing calculations using calculated variables, and using unions and joins. As usual, if you'd like to follow along with the examples in this chapter, please download the files from this location. Let's get started. Okay, let's look at what is SQL and how does it fit into SAS. Well, SQL, which is pronounced SQL, also is called the structured query language. It was first introduced by a paper by Edgar Codd in 1970 on relational models. The idea was then developed at IBM in the early 1970s and standardized in 1986 by the American National Standards Institute. In the 1970s, also relational software, now Oracle, developed a SQL version, and in 1979 they introduced the first commercial version of SQL. IBM also introduced versions of SQL beginning in 1979. In 1992, Microsoft introduced Microsoft SQL, and other implementations followed, including MySQL, Progress SQL, and SAP. Early SAS PROC SQL was introduced about 1990 in SAS version 6.06. The current SAS PROC SQL was introduced in version 8 in 1999. Now, most companies now depend on some SQL implementation for data management. And when you learn SAS's PROC SQL, you'll have knowledge of how most other SQL implementations work. So how is SQL useful in SAS? SQL is used for selecting, subsetting, or modifying data from larger databases using robust selection criteria. It's similar to but different from the SAS dataset statements where we use set, if, where, and so on. It's also very good at ordering and sorting data using different and sometimes more powerful techniques than you can do in PROC sort. It provides a way of restructuring a data set that's not easily performed in standard SAS routines. It provides ways of combining data sets that are not easily accomplished in the SAS data step. But it is not generally used to analyze data, only to format data, to reorganize data, and to clean up data sets and getting them ready for analysis. So the basic concepts for SAS SQL, a couple of terms that we need to talk about. First is the query. A query is used to describe the process of requesting data from a data set or database. Query is a term not usually used in the SAS data step, but it's part of the common language for SQL. Also, the term view is a common SQL term, which is used to describe the default results of the SQL queries. It's almost like a PROC print, as we're going to see. So SQL looks at data sets a little differently from SAS. SAS looks at a data set one record at a time, so it's a sort of a sequential implied loop that moves from the first record to the last, whereas SQL sort of looks at all the records at once as a single object. Because of this difference, SQL can easily do a few things that are more difficult to do in SAS. So here's the simple procedure to use SAS, a simple PROC SQL. You can do it with only 3 statements. So here it is, PROC SQL, SQL, semicolon, and then select star or asterisk from some data set name, mysaslive.sumdata, and then quit. So this program selects all variables indicated by the star from the SumData dataset that's in the MySAS library. It's important to note that the results of the SQL query, the view, in these early examples, doesn't actually create any new dataset. It just displays the result of the query. Again, as I mentioned, sort of like a proc print. So here's some terminology. Here's a SQL term, a SAS term, and also I threw in a data processing term. So in SQL, we refer to a table, whereas in SAS, we often talk about the SAS data file or data set, whereas data processing term is simply a file. SQL talks about rows. SAS often use observations. Data processing uses records. Sometimes these are used in all three. A SQL term talks about the column of data. SAS talks about variables, and data processing uses fields. Okay, so here's the first hands-on example. If you open up the program file SQL1.SAS and run the code, it's the same code we saw earlier, this is the resulting view. So you'll see here it looks again like a little bit like a proc print where we have columns of data with headers on the top of the table that has been produced, ID number, intervention group, and so forth, and all of the information. Now this is only part of the table. It's longer than this, but you get the idea. So again, here is the structure of a SQL statement. We're going to use this same structure here for a number of examples and just sort of add to it as we go along. But here we have proc SQL. We already saw select star from MySASData.SumData, and then let's throw in a new statement, order by ID. And I think you can guess what that's going to do. It's going to order the output by the variable called ID. Notice here that there's no semicolon until we finish the select statement. So the order by statement is within the select statement. So a common error is to put a semicolon where it doesn't belong. So it goes all the way to the end of the select statement. All right, the select statement is the primary and most important statement in proc SQL. We always begin with a proc SQL statement, but then the select statement tells SAS what variables to display and where to get the information. The asterisk or star means to display all variables. And we'll learn more options in just a little bit about how to display only selected variables. The from clause indicates the data set that contains the data to use in the select. And in the case of this example we just looked at, the order by ID provides additional instruction that's going to tell proc SQL to display the data in a certain order. And finally, we end with a quit statement. So here again, we're going to add to this a little bit. Open up the program this time called SQL2.SAS and notice what it looks like. First of all, we have select, and we're going to list a few variables. Now notice there's a comma between them. So ID, comma, group, comma, age. And then where's it coming from? From the data set called SumData. And now I'm throwing in a couple of other things here where gender contains female. And I think, again, you can sort of understand what that's doing there. And then we also still have order by ID. So in this case, we're saying get these variables from SumData, only include the ones that contains the word female in gender, and display the results ordered by ID. And so here we have our results. Notice we have ID number, and notice it's in the order of the ID number. Notice we don't have any gender column. We told it to only use data from that match females, but it doesn't show up anywhere in here. And the reason is it will only list those things that are, those variables that are listed in the ID, in the select statement. So notice here, we only have 3 variables listed, ID, group, and age. That's the only ones that are going to appear in the view. And so we see those 3 appeared. This is only for female subjects, but female doesn't appear because we didn't ask for it to appear as one of the columns. All right, so we see already that there are several statements within the select statement that we can add to provide additional information. So let's sort of look at those. First of all, the select statement obviously begins with the word select. and then we start listing the columns we want to include in our view. We also have the from statement that's going to tell where the data is coming from. We have a where statement that allows us to choose specific parts of our data set depending on whether they match an expression or not. We can have group by. Again, all these are fairly commonly understood. We're going to group certain columns by some variable. Having is a little bit more obscure, but we'll talk about it in a minute. And then order by is like having it in a sorted way, the view. Okay, so let's modify this SQL2.SAS program that we opened earlier. So here, notice that I'm putting them in the wrong order. Now, let me go back just a second and just make a note that it's important that when you use these statements that they appear in this order. SQL is very dependent on having this order used, and so if you move things out of order, you're going to get in trouble. So what we've done here in this, by modifying the SQL2 thing, is we've reversed the order of order by ID in the where statements. So what happens if we try to run this program? Well, we get an error message, and this is what you would see in the log, where it looks at where the where statement is not where it is expected, and so it produces this error with a lot of stuff listed here. All right, now let's look at using the select statement, some variable selection ways within the select statement. So here we've already seen the select star or asterisk, which means all the variables within the data set. We could also list them with commas separating ID, gender, age. We can use the dash dash like we did in the procs or in the data step, where that just means all the variables between ID and time 4. Or if they're in sequential order, we can use a single dash, time 1 dash time 4. We can combine those, ID, comma, time 1 through time 4, and gender. Notice they're all separated by commas. And then the last one, food expense, income, and then notice the last one, age as age 2020. Now what that does is so we have 3 columns here, food expense, income, and then this last column, which is going to be named age 2020. So we call that an alias, age as alias, age 2020. That's what that's going to do is instead of the column being named age, it'll be named age 2020. We're going to see that often and commonly used. So, for instance, let's look at this way to create a variable using a case statement. In this example, we begin, first of all, we have select ID, comma, so we have one column defined, ID. Now we go to the second column. We're going to create a column called what? Well, we don't know yet. We're using this case GP statement. You have to look all the way to the end of the case GP statement. Notice there's an end, and then you see as treatment. So we're creating a second column called treatment by using this information in the case GP statement. And this statement says when GP is A, then the value of treatment is going to be TRT1. When the value of GP is B, then the value of treatment is 2. Otherwise, or else, the value of treatment is control. All right, let's look at some other things we can do within the select statement, and that is we could apply some formats and some labels. And again, this you should be fairly familiar with this, very similar to what we would do in data steps. Here we have select food expense and then income, and notice there's not a comma here yet. Income and then a format equal $72. So we're applying the format called $72 to the variable called income. So when the income column is displayed, it's going to be displayed using that format. And then there's a comma, which means go to the next column. Age is the name of that column, but we're going to label that column age in 2020. Another way to change the column name as it appears. And then finally, comma, own rent. So we've defined several columns here, and notice each column is separated by a comma. All right, so let's take a look at a program, example 9.3. Open up the program file called SQL3.SAS and you'll see this code. Here we have a select statement, ID, group, age, gender, and then we have a case statement. Now remember, go all the way to the end, so we go to the word end, and then we see as treatment. So again, this is going to create a variable called treatment, a column called treatment, and followed by the final column that's going to be called status. And here we see the results. The second to the last column is named treatment, and we see the contents of that column was defined by this case statement, which is either going to be TRT1 or TRT2, depending on the value of the variable GP. All right, we can also use SAS functions to create modified values. And again, these functions many of these functions are listed in the appendix. So if you want to know about more that you could use or what these exactly mean, you can look there. But here's an example. Select, and that's a substring function, substring brand, comma 1, comma 4, which means start with the first character in the word brand and keep only the first 4 characters. So the first column, brand, is only going to contain the first 4 characters of the variable called brand. Then we go to the next column, model, then city, miles per gallon. In a second example, here we have select round of food expense. So this is going to give the default round value for the variable called food expense. The column will be named food expense, but it will be displayed as a rounded value rather than whatever the value was in the actual data set. All right, so let's look at an example. Here's example 9.4. Open up the program file called SQL4.SAS. Now you notice we're going a little bit back to regular SAS for a moment to create a data set called room size. We've seen this data set before, but here we're reading in a room name like living, and then the width and the length, and then the at says continue to read until you run out of rooms. All right, once we've created that data set, we can then use that data set within PROC SQL. So we do PROC SQL select all the variables. So we have 3 variables, room, width, length. But now we're going to create a new variable. Look at all the way to the end as area. That's the alias. So we're going to create a new variable called area. How? We're going to round a expression width by length, and then the comma 0.01 means to round it to 2 decimal places, display it as 2 decimal places using the format 6.2, and name it area. So again, here's the results. We see the first 3 columns were the original data from the data set, and then the last column is area, which we have defined by this round statement and the as area alias to give it a name. All right, now let's take a look at 9.3 using the from statement in PROC SQL. So we've seen this before, but let's just talk about it a little bit. Here we have PROC SQL select all variables star from, and the first instance here we're just using the normal data set called some data that is within this My SAS Lib library. So that's one way to name a data set name. Or, second example, we could use the Windows version of how to name a data set. This one was in quotes. Notice the difference. The first one not in quotes. This one is within quotes when it refers to a Windows data set file name. SAS data, my family. And then finally, the one at the end, which just simply says from my data. And we should all be familiar with the fact that when we have just one name there, it means a work file or a temporary file that we have created. All right, let's look at 9.4, creating SAS data sets. So I've mentioned several times that SQL doesn't actually create that data set that is displayed. It's simply a view, sort of like a proc print. So what if we wanted to, in our query, we want to create this new columns and things like that, but we also want to save the results. And so there is a way to do that, and this is with a statement called create table that we'll look at now. So here's how you do that. So here we have PROC SQL before the select statement. Notice this is before the select statement. We say create table myQuery. So that's going to create a SAS dataset called myQuery as select all the data from mysaslab.sumdata. Now notice here again we say create table. That's the word for a data set in SQL terminology. So we're creating a table called myQuery, which is basically the same thing as a SAS data set, and we're using SQL to create it from an existing data set. And then if we do this and run it, we look at the SAS log and we see this note, table work.myQuery was created with 50 rows and 10 columns. And you can also use other ways to look at this data set. You could do a proc print, you could go to the viewer and double click on it and see the contents that way. So let's do hands-on example 9.5. So we're going to go back to the program file sql1.sas, and we're going to change the code a little bit. At the very beginning, we're going to add this statement, create table new one as, right before the select statement. So here we have, this was our original program, PROC SQL select. So we're going to add this create table new one as, and then the word SQL, no semicolon after the word as, and then select. And then we run the result, and we see that this is displayed. This is the view here where we have displayed the information that we requested, but also if we look at the log, again, we see the table work.new was created with 50 rows and 10 columns. So again, the create table statement allows you to, whatever view you have created in SQL, you can then capture as a SAS data set. All right, let's now look at the where clause, which, there was a where clause in the data step. This may be a little bit different, but the where clause allows us to select a portion of the data set on a logical specification. So in many ways, it's the same as what we've seen earlier. In this case, we say select star from the data set called SumData, where age is less than 12. So that should be familiar to you. That's exactly how we would write a where statement in a data step, where age less than 12. And we should know what that's going to mean is the results of this select statement is only going to display the values where age is less than 12. All right, so there are other where clauses we could use. Here's an example where complication contains pneumonia. Now what that means is it looks at the variable, the contents of a record under the variable complication. If it contains the word pneumonia somewhere in that information, that is a true. So it would say yes, that I'm going to include this statement. So here we have two versions of this down below, just to give you some more information about that. So here we have where uppercase complication contains pneumonia. In this case, the resulting view contains both pneumonia and aspiration pneumonia records. You can see here, both of them contain the word pneumonia. Now when you uppercase them, now they're going to be that uppercase pneumonia. So in this case, if I say where complication contains pneumonia, then both of those records would be included. However, if I just say where uppercase complication equal pneumonia, it has to be specifically only pneumonia, and it's only going to include the records where pneumonia is the only value within communication for a particular record. All right, so let's look now at another example, 9.6. In this case, open the program file sql2.sas, and here we have a simple program here where we have select ID, group, age, and then we're going to have where gender contains female. I'm going to add that, where gender contains female, order by ID. Now, count the number of columns in this. We have 1, ID, 2, group, 3 age. Notice there is no other comma. So those are the only 3 columns that are going to be in this. We've seen this program before, but we're just looking now at the fact that this where statement, even though we use gender in the where statement, it does not appear in the output because we didn't ask for it in the select statement. And so again, we have only the 3 columns we specifically requested. Now, an exercise would be to add the necessary code to include gender in the output view. Very simple, just add the word gender, comma gender, in the select statement, and it will then appear. Okay, let's look at section 9.6, using a group by clause in PROC SQL. The group clause in the select statement allows you to display output by some grouping variable. So here's an example of code using the group clause. We say select, and then we have a variable called group, and then we're going to actually have a second column called, it's the count of group, and we're going to call it in, and then time 1, time 2. We're going to have another column called time 1 max, that's going to be the maximum of time 1, formatted as 6.2. And then we're also going to say group it by the variable GP. So group by group causes it to display the results grouped by the variable group. And so we see now the 2 things actually that we did. On the far left, we see the variable or the results grouped by intervention groups alphabetically. So here we have all of the A groups and then followed by all the B groups and so on. And we also see this new variable that we created that was the max of time 1, formatted as 6.2 and named time 1 max. Also, the second column is in, which is the count of the variables in A. So there are 11 people or subjects in group A, and so that in is 11 throughout the time, and then there are 29 Bs and so forth. You know, that might be a variable that you need to use, for instance, in some sort of calculation, or whatever you want to do to display it. Okay, first of all, so this goes into a little bit more detail. So in is used creating the count function. So when we say count group as in, we create the count of however many people are in that group, like the A group, and then we display them using the alias in. And as we mentioned, and also the time 1 max was created using the function max, which gives the maximum time 1 of time 1, and we call it again time 1 max. I'll go back just a second, and again we can see that the maximum of time 1 in this case was a 23 within the group, and then when the group became B, the maximum was 24.2. So it's the maximum time 1 within the group. Again, the by group causes it to separate those and give us the maximum time for all of the variables in time 1 for group A and then group B and so on. In fact, we can see probably in here somewhere 23 is the second to the last value in the A group. All right, now let's do example 9.7. So open up the file called SQL6.SAS, and this is just a little exercise here that is going to ask you to fill in some blanks. So what we want to do is fill in the blanks to display a column for the minimum of city miles per gallon by brand, and then we want to save the results in a table named cars MPG in the work library. So we're sort of putting together a few of the things we just learned. So we're going to have create table. What's the name of the table that we're wanting to save? It says there. And we've already calculated the max of city miles per gallon. The minimum of city miles per gallon should be very simple to do. So you can fill in the blank there. And then we also tell you what we want to group it by, and that is brand. So here's the result. Hopefully it was easy. You got those right. So as you can see, we can create new variables and choose how we want to group things depending on what we want to do. And here are the results. In this case, we grouped by brand, so Acura became the brand with the earliest in the alphabet. And we have city miles per gallon, highway miles per gallon, and then notice here we have city max. So 27 miles per gallon was the maximum city miles per gallon for Acura. The minimum was 17, and then it switches over to Audi, and then we'll have a different city max and city min. And there's some more steps in this example that you can do in the text. Now let's look at this using a having clause. The having clause is used with a group by clause to specify conditions for selecting which group results appear in your results. So again, we have a group by clause. So for instance, in the previous case, we had group by brand, but what if we didn't want to display all the brands? Then we can also add a having clause that would give us an additional selection. So let's open up the program file called SQL7.SAS, and we see this code where we're going to select all the variables from a file called accidents. We're going to group it by gender, and then we only want to display the records having an ISS value greater than 5. That's injury severity score. So this is a real data set of accidents. And when the paramedics come, they assess the person. They give them an ISS score, which is an injury severity score. If it's greater than 5, that means that they've had a fairly serious injury. So we want to display only those people in this listing that have fairly serious injuries. So here we have again it's grouped by gender, and so female appears first. And then we have the injury severity score. Notice all of them are greater than 5. So if we continued further down here, we would eventually get to males, and we would see similar kinds of things in the gender grouping of males. Now, why not a where clause instead of a having clause? Now, you might think that you could use a where clause instead of a having clause because they seem to behave similarly, but there's a slight difference. Having places conditions on a group created by group by, whereas where places conditions on the column. So as we noted, when we use having, we also have a group by. So having applies conditions on a group, whereas the where clause applies conditions to a column. All right, let's look at section 9.8, using an order by clause. So we've seen order by, but order by sorts a data set in ascending or descending order. The default is ascending. For example, the following code creates a view of phone numbers ordered by in ascending order, first name, and then first name within last name. So here we have select last, first, and then phone from a list of phone numbers. And we're going to order it by last, comma, first. Now again, this is halfway similar to proc sort, where we're going to order by last, and then within last names that are the same, we'll order first name. So let's take a look. Open the program file SQL8.SAS, and here we have a little telephone directory for an ABC company, and we have the same code that we just saw earlier, where we're going to order by last, comma, first. And here we have our results. So we notice that this is ordered by last name from Adams to Zoll. And then notice there are 2 Joneses, and then within Jones, Jackie and Pam are in alphabetical order, and also Smith, Adam, Arnold, Bev, and John are alphabetized within Smith. So that's how that would then work. Now there are some quick tips sheets that are available. You can download them at this location at alanelliott.com.sas, and you can print these out. I like to print them out double-sided on a thicker sheet of paper, and then you can use these as reference to using SQL. But now let's go to a couple of sections where we're going to look at some deeper items within PROC SQL. Obviously, we're not We're going to be able to cover everything within SQL. This is an overview and introduction, so we're just sort of hitting the high points, but these are some of the most important things within PROC SQL. First of all, let's look at calculated values. So here we have select group. We've seen this some of this same file before, but we have added something here. So we're going to have a variable that we're going to have show look at the as time to adjust, time to ADJ. And this value is calculated round time to divided by calculated time 1 max. Now, why did we have this calculated word here? And the reason we had it is because time max is not in the original data set. Time 1 max is a calculated value in the previous column. So notice here we have max time 1, format 6.2 as time 1 max. So if we use a value that has been calculated within the select statement, we have to tell SAS, oh, by the way, we're using a value that has just been calculated. Don't look in the original data set, look in the calculated values. And so that's why we have this word calculated here before time 1 max, because that is a calculated value. Now, what if we left off the calculated statement, or that word, what if we just left it out? Well, you can take it out and run the program, and you'll see that it creates an error message. The following columns were not found in the contributing table. So it couldn't find time 1 max because it looked in the original data set, but it wasn't there. So SQL didn't know where to find that value. We have to tell it that it was a calculated value. If we put it back in and rerun it, voila, there it is. It did all the calculation correctly, and we see the results here. Now let's look at another section here, and that is unions and joins. Now this is a huge issue or a huge ability within SAS, and again, we're just doing a quick overview of it just to show you what it is. But basically, it's similar to what we did in SAS with combining data sets, either appending or merging data sets. So SQL unions and joins provide a oftentimes quicker and easier way to combine data sets than using the SAS data step. So here's a typical code here. We have to say PROC SQL, select all the data from old 1, union, select all the data from old 2. What this does is it appends the two data sets, old 1 and old 2, and so we have a view that contains all the information. Here it is an example. So open up the file called sql10.sas, and we see that we have two data sets. One called old 1 that we're creating. This is just within regular SAS data step. And we have another one called old 2. Notice there's a little bit of difference between them. First of all, old 2 has a value called married, whereas old 1 does not have that value in there. So we're going to see what happens when we try to put these together. So let's take a look at what that does. Just a note here, because old 1 doesn't have a married value in the append data sets, the values are going to be set to missing in the view. Also, because the record for subject 006 is the same for both in old 1 and old 2, it's listed only once in the view. So notice here you have 006 is a variable that, or a record that's in both variables, both data sets. But because when we combine them, it's only going to list it once, so it doesn't duplicate variables that we happen to be trying to combine. So again, here we have the result. Notice here I've highlighted 006, it's only in there once. And also I've highlighted the column called married. The first few values didn't have a married variable, and so it ends up being missing values, whereas the second old 2 data set, which we combined with it, does have very married values, and so they're included here in the combined files. There's also some other steps in this example if you want to follow them in the text. Now there's various different kinds of SQL unions, and we're not going to have examples of all of these, but you can play with them and see what they do, or look in the text and it explains it in more detail. But we have the union, which we saw, produces all unique rows for both queries. So that's why the 006 was not in both, because it only produces the unique rows. Except produces rows that are part of the first query only. Intersect produces rows that are common to both query results. So 6 would be the one that's common to both. Union all produces rows from both queries. And outer union concatenates the query results, which is a little odd, but I suppose it can be used sometimes. Okay, now let's look at using SQL joins. Another method of combining data from multiple datasets is the join command. This technique joins datasets horizontally. So whereas the union combined datasets vertically, join typically adds more variables. And so we call that technique a horizontal combination. So for example, here's how you would use join, and we'll look at this in detail as we go along. But here we have proc SQL select everything from old one. And then we have inner join old one on old one.subject equal old one dot the word subject. So here we have in the data set called old one, there is a variable called subject subj, whereas in old two, the same variable is called subject. So we did an inner join by matching those two variables. And by the way that this works is that the old one dot says this variable is from the old one data set. The old two dot says subject, the spelled out subject, is from the old two data sets. That's how you differentiate variables from the various data sets with their name dot and then the variable name. All right, so let's open up a program file called SQL11.SAS and look at, again, we've created the two data sets, old one and old two. And now we're going to do the proc SQL select all from old one, and again, notice and inner join old two. Now notice again, look at data set old one, and the input subj is the first variable, whereas in data old two, the variable is named, spelled out, the word subject. It's the same variable in the same format, but it's spelled differently. Therefore, we have to add this on old one.subject equal old two.subject. If they were both named the same, we could just say on subject. All right, so now that we run that, we see how the data sets were joined together. In this case, we have subject 3, age 44 years, smoke, there's subject 3, subject and married. So we added a new columns of variables. And also note that since no subject 11 was included because there was no match. Let's go back a second and see that old 2 had a subject number 011, but old who didn't have that subject on there. So when we combined them, it only combined in this version of join, it only combined the records that had matching values on the two items that we listed. Those are very, again, just like in unions, there's a variety of types of joins. So we have an inner join, which selects records for observations in the two data sets have matching key values. Again, that was the one we just looked at, and 11 was not included because it didn't have a matching key value. We have right outer joins, which is similar to an inner join, with rows from the right or second table that do not match any row from the other table included in the join. And again, you have to be really careful and look at the various versions of this. Now, the thing is, doing these unions and joins, once you understand what is happening in all these, it's a much easier way to have this simple statement than to do the things you would need to do in proc in a data step within regular SAS. So once you get to know these, it makes doing some sort of specialty joins and unions much easier. So the left outer join is the same as the right outer join, except variables in the left or first table that do not match any row from the other table are included. And then the full outer join returns all rows from the left table and the right table. That way, that is, it combines the results of the left and outer joins. And again, we have these quick reference sheets that you can download, and it has some specific visual looks at what the various joins and unions are, as well as all of the SQL statements that we covered, plus a few statements that we didn't cover. Just a little blown up value of this sort of gives you a visual look at what these various unions do. For instance, you can sort of see what's happening in the union produces all unique rows at the very first. Union all produces rows from both queries, may produce the same results, etc. And so you can go through there and see what they are and maybe get a better idea of what's happening with these sort of Venn charts here. All right, so that's the end of this introduction to SQL. Again, it was only an overview of SQL. The text contains some additional information if you want to dive deeper into SQL that we encourage you to do. Our next chapter is going to be evaluating quantitative data. And so we appreciate you watching this tutorial. I hope it was helpful to you. If it was, please subscribe and like. Thanks.